Welcome, and we are going to get started. Can talk a little bit about um, geometric growth and the sequences that are formed with geometric growth. So just like an arithmetic sequence is described with arithmetic growth, a geometric sequence is a one way to describe geometric growth. It is a sequence created by multiplying the previous term by the same value to get the next term. So an example, the sequence 4, 8, 16, 32, where we're multiplying by 2 each time, would be a geometric sequence. The value that you multiply by is called the common ratio and is shown by the letter R. So it can be found by taking any term and dividing by the previous term to find that common ratio. So just like with arithmetic sequences, we're going to describe a geometric sequence using formulas or equations. So we could use a recursive formula or a recursive equation. Again, you have to be given a starting value, a1. Then the recursive equation says to get the next term, we take the previous term and multiply by r. The explicit formula, a sub n, would be the starting value, a sub 1, times r to the n minus first power. And yesterday we found the sum of the arithmetic terms in an arithmetic sequence. So today we're actually going to find the sum of terms in a geometric sequence. And so there is a formula for that. So to find the sum of the first n terms, you're going to take the first term times the common ratio to the nth power minus 1 divided by the common ratio minus 1. Excuse me. And again, I would suggest somehow marking that formula just like I would mark the formula from yesterday, so it's easy to reference in your notes. All right. So similar to yesterday, we're going to write a recursive description or a recursive equation and use it to find the sixth term in our sequence. Write an explicit, that really says description. There we go. and use it to find the 25th term in the sequence, and then find the sum of the first 25 terms. So here is our first sequence, 1, 2, 4, 8. So our recursive definition, a sub 1 is 1. And our recursive definition says take whichever, take your previous term and multiply it by 2 to get your next term. The sixth term, if I use the recursive definition, I already know what term 1, 2, 3, and 4 are. So the fifth term I would multiply by 2 and get 16. And my sixth term, I'll write those down, although I think you could probably do that in your head. For the explicit definition, it would be 1 times 2 to the n minus 1. So to find the 25th term, we would have 1 times 2 to the 25 minus 1, or 1 to the 2 to the 24th power. $16,777,216. Good thing we didn't have to use the recursive definition for that one. That would not have been fun. And then the sum for the first 25 terms. So again, I'm going to use S for the sum. Excuse me. And I'm going to remind myself and you of what the formula is. So it's the first term times the common ratio to the nth power minus 1 divided by the common ratio minus 1. So the first term times the common ratio to the nth power. So that's the 25th power minus 1 divided by 2 minus 1. So this is really just going to be 2 to the 25th minus 1. So this was 2 to the 24th. So 2 to the 25th would be 33,000, or 33,554,432. And subtract 1. I'm going to run out of room. Whew. Okay, there we go. All right. For this sequence, we start at 7. The general term, or the recursive definition, we're going to multiply by 1/10, or I'll write it as a decimal. We're going to multiply by 0.1. So we have 1, 2, 3, 4. Our 6th term with 3 zeros and a 7, and then with 4 zeros and a 7. Our explicit formula, 7 times 0.1 to the n minus 1. Again, you could write it as 1/10 as well. Using it as a decimal, kind of nice if you're using a calculator. And I have a feeling this is going to come out in scientific notation. Yeah, so it's going to be 23 zeros and a 7, or 7 times 10 to the negative 24th. More fun to write it out, I think. I don't know. All right, our sum. So 7 times 0.1 to the 25th minus 1 over our common ratio is why does that not look right to me? Oh, come on now. Here we go. Okay. 0.1 minus 1. And actually, the sum is pretty easy. You may not have even needed a calculator because we know we're going to get the 7.7777 all the way down. We're going to get 24 sevens. Excuse me. And the last one. So again, having one with a positive common ratio, this one has a decimal as a common ratio. This one's going to have a negative value. As the common ratio. So our sixth term is 160. Our general, or our explicit form, -5 times -2 to the n minus 1. And the 25th term, -83,886,080. And our sum of the first 25 terms, -5 times -2 to the 25th minus 1 over -2 minus 1. And I get -55,924,055. Hopefully you did that along with me and double checked and made sure I did it right. Yes? It's okay to check my work. I do. So today you'll do some geometric sequences, and then tomorrow we'll do some application problems. Have a great rest of the day.